Yeah. All right, so let's take a look at slope. Okay, section 11.1. So slope, we're going to talk about it in terms of like a line, but there's a lot of areas in real life that slope might come into play. What's another word for slope? What does slope really measure? Not quite an angle, but I can see what you might mean by that. Like if you were walking up a hill, you wouldn't say, wow, this hill's got a big slope. You might say, if you're getting tired, it's what? How steep it is, right? So,
But they do have prices and stuff.
Prices?
Like the money, they use steep.
Like what do you mean with money?
Like they use slope, right? When it comes to money.
Well, there's different graphs you might make having to do with money, like maybe like prices of gold or stocks. I don't know if you mean something like that.
Yeah.
You can watch the changes. But anybody think of another example where slope or steepness is used? Maybe by different occupations or trades or...
Oh, you're going to a mountain.
A mountain? Yeah. So mountains definitely have a slope.
Or maybe like snowboarding.
Okay. A lot of times when I hike, I take a GPS with me, and it tracks my position where I am. And then when I'm done, I can look at it on Google, and it'll show me like the steepest part that I went up. You know, all kinds of different statistics. So that's kind of cool. So mountains. Has anybody ever been on Mount Washington?
Washington.
Yeah, if you go on Mount Washington, the Cog Railroad.
I've been to the White Mountain.
Yeah, it's up in the White Mountains. If you take the Cog Railroad, they usually have this little spiel they give you about how it was built and all this stuff. And then at one point, they tell you how steep it is. I forget the exact steepness of it, but it's extremely steep, very steep. I think it's almost like a 40% grade. It's very, very steep in some parts. Has anybody ever seen that, like signs on the side of the road that say like 8% grade? It's like usually a yellow sign. Looks something like that. Okay.
I've seen one of them before.
This is telling you the grade of the road. Okay, so for trucks that's important because if it's really, really steep, okay, what they got to do is shift into a lower gear. There's no roads around here that are 26% grade. Going from Fitchburg like into Leominster, like Merriam Ave down that area, there's a sign and I think it says 8% grade. So this is a little steeper than that. This is extremely steep. Basically what that means is for every 100 feet the road goes forward, it drops down 26. For every 100 it goes forward, it drops down 26. Okay? And this one's going for, I think it says the next 10 miles. So that's probably out, I would probably guess this is out west. Probably high up in a mountain heading down. Yeah. Anybody think of any other place you use slope? How about construction trades? There's a lot of different construction things that have to do with...
Building a building on like a steep hill.
Yeah. So hills that can play into building, you got to think about drainage and the runoff. So you want to make sure the land is sloped away from the house. If the land is sloped towards the house, when it rains, all the water, it's going to head downhill towards the house. You don't want that. So you got to think about that. What else about a house?
The roof.
The roof. Okay, and a roof, they don't usually call it slope. It's called, anybody know? Think of something you do in baseball when you throw the ball.
Pitch.
The pitch, all right? You get the pitch of a roof. Different roofs have different pitches. Around here, a lot of houses don't have flat roofs. You might see schools or supermarkets. But in the West, more houses have flatter roofs because they don't have to worry as much about what? Snow. You still get the rain, but the snow is the big problem. So we have pitched roofs, so the snow comes off it. Any other examples people can think of where you might use steepness? Okay, another one is for wheelchair ramps. Okay, American with Disabilities Act, there's certain codes that talk about the slope and the rise of a wheelchair ramp. Okay, this one says the least possible slope shall be used for any ramp. Okay, the more shallow the slope, the easier it is for the person to get up it. And it says the maximum slope of any ramp in new construction has to be a ratio of 1 to 12. Okay, that means for every 12 feet the ramp goes forward, it can go up 1. So it's like 12 feet forward, up 1. 12 feet forward, up 1. That's the steepest that it can be. Right? So there's codes in construction for these kinds of things too. And all of this has to do with slope. We, in this class, don't usually write slope as a ratio 1 to 12. We find it more as just a number. But basically, it's going to be like the idea of rise divided by run. We don't use the colon, though. We write it as a fraction. So we would write this as 1 over 12 as a fraction. Right? And all kinds of other things, too. But spacing on the ramp, the minimum width of the ramp. But I'm just trying to show you guys an example with slope. All right? Okay, any questions on that?
Is this gonna be on the test?
Slope, yep. Yep, you see slope on the test.
Also, the Hager would have on there all the different laws and stuff for the wheelchair ramps.
Gotcha.
Okay, walking
Make
upstairs.
sure you know that stuff. Right?
Probably be in a-
Okay. Yeah, stairs. You can think of stairs as a slope. It's not really a ramp, but there's a rise and a run. Okay, walking or pedaling up a hill on a bike, you have a slope. And so now let's look at mathematically how we define slope. Okay, so slope, or the steepness, it's a ratio of two things: rise to run. Okay, rise measures vertical. So if you think of like a stairway, here's a set of stairs. This part right here, that's the rise. Okay? It's the part you step up. It's called the riser. The part that you step onto, that's the tread. Okay? That's called the run. Okay? If you make either one of those not the right measurement, it could be a difficult stairway for somebody to walk up. If the rise is too big, people have to step too high. If the tread or the run is too short, then people don't have enough of a landing to step on. It could be tricky. Right? So there's your rise and your run in a stairway.
Like, I've seen stairways that have a bunch of stairs and a long, flat stair.
Yeah?
There's a big flat one, then more stairs, and
Yeah.
a flat
Did
one.
you see that? in his-
Yeah, I guess sometimes they might do that just to kind of give people a spot, like if it's a really long stairway, just to give people a spot to rest. If you go different places, there's some waterfalls in different countries, and they have a set of stairs to go up to the top of it. And every now and then they put a really big stair, just so that if you're getting tired, you can kind of step to the side and other people can go up. But that's probably one use for something like that. Okay, here's an example of a hill. Okay. In this case, the hill, if you were just looking at it, or think of it as a ramp, looking at it from the side, has a run of 50 feet and a rise of 20. Okay, so the way you could find the slope of this hill is you take the rise, that's the vertical, which is 20, and you divide by the run, which is 50. Now, anytime we have slope, we always reduce it. Okay, if you can reduce it as much as you can. And what number goes into 20 and 50? 10. Yeah, so we could say this hill has a slope of 2/5. Okay, meaning for every 2 feet you go up, it goes 5 feet forward. So it's 2 feet up, 5 feet forward. 2 feet up, 5 feet forward. Right? And if you were to draw that line in, there's your hill right there. Okay? So that's what I just said. For every 2 feet you go up, you go 5 feet forward. So any question on that idea? So that's how we measure the steepness. We don't usually measure an angle. Okay, angle, you could tie that in with the idea of slope, but an angle itself is not slope. Okay. So what we're going to do is find the slope of lines in a coordinate plane. Okay, what's nice about a line is lines are what? When you draw them. They're easy to draw because they're versus like a circle. What's the difference? They're straight, right? So the slope of a line, it's the same. Okay? If you were standing on a hill here and you yelled down, you say, Ryan, what's the slope down there? Right? It's the same as if you yelled back up to me and said, Mr. Hager, what's the slope up there? Right? It's the same slope everywhere. Okay, it doesn't matter where you stand. Same slope. When you get into something that's curved, like that picture on the calculator over there, that gets a little tricky because now the slope is changing all the time. Okay, like a roller coaster. Maybe it's flat at one point, then it drops down fast, and then it goes back up. But we're going to look at things that are nice and straight. Okay, so it makes it a lot simpler. Okay, and one way you can find the slope is to take 2 points and graph them. Okay, we'll use graph paper.
Yeah, so we're gonna do slope 2 ways today, guys. This is the first way where you're given the graph and you can you might graph the 2 points. Maybe they're already graphed for you, and what you're just gonna be able to do is you'll be able to count what the slope is and not have to do any kind of math.
All right, so let's say I had a point here and then a point here. Okay, all I got to do is count how many up and how many over. Okay? So the first thing you want to count is the vertical. Okay, the up and the down. Okay? If you count up is positive. So in this case, if I go up, that's up 1. Okay? If I went down would be negative. And it turns out it doesn't really matter which dot you start at. Okay? If I go up and then right, or if I said I'm going to go down and then left, it's going to come out the same. Right? But I decided to start at the dot down here. Okay? So I went up 1. And then after you count the vertical, what other thing do you have to count? Besides the up and the down. You got to count the left and the right, the horizontal. Okay. Between the 2 directions here, left and right, anybody have an idea which one might be the positive? Yeah. If you head to the right, think of like right on a number line. Right is positive. Left is negative. Okay, so on this one, I went up 1, and then which direction did I go after I go up? Do I go right or do I go left? Sabrina?
Wait, what was it again?
So we went up and to the,
Oh, left.
so we went to the left.
Oh, I meant right.
Yeah, we went to the right. How many?
2.
2. Okay, we went up 1, which is positive 1. We went right 2, which is positive. So we had a positive over a positive, which is a positive. Okay? What if I ended up with a positive over a negative? What kind of number is that? About Alex, what kind of number is positive over negative? Like if you do arithmetic with that.
Oh, negative.
Negative, yeah. All right. What about if we did negative over negative? What kind of number would that be? Positive, and we're going to mention that later on.
So guys, everything that's bold up there, you're gonna want to fill in on your notes, and also the stuff after, like, it's you have on your sheet, you have up equals, you have to write it in positive. Down equals, write it in negative.
So when we write slope as a fraction, okay, you write it as rise over run. Rise is the up and down, run is the left or right. Now, can you flip it? And would it be the same thing? Like if I had this as a slope? If I flip it, is it the same slope? No. There's a big difference between 1 over 2 and 2 over 1. Okay? Big difference. So make sure when you write the slope, rise is on top, run is on the bottom. You can't switch it.
You guys said that. You guys said this have a line on there, so you write rise up or down on the top, and then run left or right on the bottom on that line. Most of you guys wrote that one, which is good.
Okay, and there's really 4 different cases we can have for slope. Okay. Does everybody have rise over run? You got that? Okay. So here's our 4 cases. Okay? And we always look at it like we're going to the right. Okay? Look at it that way, like you're walking towards the right. If you were walking right, what kind of hill would this be? Uphill or downhill? Up. Up. What do you think of when you think up? Is that positive or negative? Positive. Okay? So this is a positive slope. Okay, the one below it, if you were walking right,
Later.
yeah, you'd be heading down, which is a negative. Okay, so that's a positive slope, that's a negative slope. What about this one? If you were walking to the right, would you be walking up or down?
Neither.
Neither. So it's kind of right in the middle. What number is in the middle of positive and negative? 0. Right? So that's a 0 slope. And now the last one is a special case. This is as steep as you can possibly get. Yeah, it's like climbing straight up. It's like Sylvester Stallone in Cliffhanger, right? He's going straight up. So this is so steep we can't even say it's positive. It's undefined. Okay, undefined. We can't even do it. It's so steep.
Only Mr. Hager can do that.
Yeah.
I didn't like that.
All right, so those are your 4 cases.
Oh, no, it's the best of something.
No, it should have been.
Pause.
No.
Any question on those 4 cases?
Come on, reach. My eye.
All right, so as we go through some today, we might ask you guys just after we draw it, is it positive, is it negative, is it 0, or is it undefined? Okay, has everybody got that chart? I already had they already had that filled in, Mr. Roy?
No, they had to write, they had to.
Okay, good.
They had to draw the line and then write what it was.
Okay, you guys got it all? Good, all right. Okay, so just show you guys one more example. Look at this one. Got a point here, got a point here. Before I even measure the rise and the run, by the direction of the line, is it a positive or a negative?
Negative. Positive.
Positive, right? Think about if you were heading to the right. You'd be walking up, okay? Positive slope. So that means when I get my final answer, it should be positive. If you get a negative, go back and check it.
And guys, this isn't on your sheet, we're just showing you how it works. We're not on to those 2 examples on the bottom of the page yet.
Okay, so in this one, I decided to go right. Okay, and when I head to the right, okay, what kind of number, Victor? What kind of number is it when we head right?
Would it be,
What kind of number?
positive?
Positive. So in this case, it's a positive 2. What kind of number when we head up?
Still positive.
Still positive. So the rise is 3. Positive. Run is 2. That's positive. And which one goes on top? Rise or run?
Would be rise.
Rise. Rise goes on top. Rise is 3. Run is 2. That's the slope of this line. 3/2. Generally, we don't change it to a decimal. Okay, we're not going to write 1.5. It's not that it's wrong. It's just that if we write it like this, now we can't see the rise and the run. The 3 and the 2 kind of change into a decimal. All right, so we don't want that. Okay, what kind of line is this? Look at the direction of it. Michaela? Yeah, this one's negative. Okay, so if you start at this dot, you go down 5. Okay, down, that's a negative. There's your rise. And we're going right 4. Right is a positive. So this time we have a negative divided by a positive. Okay, so there's my negative slope. Okay, so any question on how you look at the picture and do that? Kevin? You good? All right. So we'll try an example, make sure we're okay. Okay. So we've got 2 points. Okay, first thing they want us to do is graph the points, draw the line, and then find the slope. All right, so first thing, this starts off with making sure we graph graph our points accurately. If we mess that up, then we're pretty much in trouble for this problem. All right, so 2, 3. Callan, can you tell me how I would graph 2, 3? Right. Yep, we're going to go right 2, up 3, and there's point A. Okay, right 2, up 3. Brian, could you tell me how I graph 7, 6? Yep, and which way is over? Right. So right 7 and then up 6. 7, 6. Okay, so there's point B. Now, technically, I could just count the rise and the run, but they asked me to graph the line. Okay, so I do have to put the line in there. Okay, so on the test, make sure you use your ID. Something to make a nice straight line. Okay, so we put in the line. All right. To measure the slope, do you guys want to start from point A or point B? It doesn't matter. Point A. All right. So start from point A. We're going to go to point B. Okay. From point A, do I go up or down to get to point B?
Down,
Down?
over.
Yeah.
I'm so confused. Hold on.
Right, up and down
First, we're
first.
gonna go
He still
over,
doesn't
then
count.
up.
You can go either one first. It doesn't matter.
Okay, so over, then up.
Okay, so Ryan wants to go right and then up. Or you can go up and then right. You're still going to get to the same spot. It's the same exact thing. Okay? So first thing we're going to do is over to the right. Okay. How many did I go right? 4. Right? 1, 2, 3, 4. Actually, 5. Yeah. Is that positive or negative?
Positive. On the dot.
So positive 5. Is that my rise or my run?
Run.
Run. Good. And now up or down? Up.
Up 3.
Go up 1, 2, 3.
That's positive.
Positive. And what is that one?
That's the rise.
That's the rise. Okay, so what's my slope? Yeah, slope is 3/5. Does anybody know the letter we use for slope? Yeah, a lot of times we use M. So if you want to write like this, it's probably a good habit to get into because we'll be doing that in future sections. And that's it. There's your slope. M equals 3/5. Does it make sense that this is positive? Does that match the line direction? What do you think? Does this positive slope match the direction I drew the line? Yeah. It's going uphill. Okay, think about it as you head to the right. It's going up. All right. Okay, let's try one more together. And we'll have you guys try 1C on your own. Okay, 1B. I've got 2, 5 and 6, 3. Rose, how do I graph 2, 5?
2, 5, you go over to one
Which way? Left or right?
side. Right.
Right 2,
And
up 5. Okay, so that's point R. Okay, and Maria, how would I graph 6, 3?
you go to the left 6 and then up.
Careful, that's a positive 6.
I mean,
Right 6. Okay, so right 6, and then up 3. That part was perfect. And that's point S. Okay, so draw our line. And before we even find the rise and the run, what kind of slope should I get here? Yeah, it's heading down as I go to the right. Okay, so right away what I'm going to do is Switch to a normal pen. The slope is negative something. All right, somebody explain how I get my rise and run. What point should I start at?
R.
Okay, we're going to start at R.
Go down 3.
Okay, down 3?
Yeah.
Sure?
2.
Yeah, let's go with down 2. It's hard to see, I think, sometimes from your seat.
Stop it.
Down 2. Okay, what kind of number is the negative 2? Rise or run? That's my rise. And we got to go to the right. How many did we go to the right? 4. And Corey, what number is that? What number is the 4? That's the run. Good. Okay, so how would we write this as a fraction? About then?
Negative 2 over 4.
Yep, negative 2 over 4. And can you reduce that at all?
Yes.
Yeah, what does that reduce to?
1/2.
Careful.
Negative 1/2?
Negative 1/2.
You got right.
Good. Okay, so anytime you can reduce it, always reduce it as much as you can. Okay, that will be mentioned in a little bit. All right. Questions on example 1B? All right.
You don't have that C, Mr. Hager?
They don't have C? Okay.
Do it on the left.
Oh, you do? Okay, yeah, I'm sorry.
All right, so why don't you guys try 1C. Okay, take a minute, graph the points, and then see if you can find the slope.
I'm done. All right? So bear with me. All right, so this one. Maria, how do I graph 2, 2? Right? Hold on, I can't think of someone in the back that is talking. An ROTC guy that, if it was first sergeant and you were talking while he was talking, come on, soldier! That's what he would have said, right? All right, so where am I going? Huh? And then what? Maria said right 2, up 2. What can I label that point, Maria? A. Excellent. Good. Ariana D, how do I graph 5, 3? Awesome, thank you. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5. And then up 3, you said, right? 1, 2, 3. And that's going to be. All right, I'm not going to be as technical as Mr. Hager. I'm just going to draw my line freehand. All right, so there's my line, right? So, am I going? Let's go from A to B, right? So to get to the point that the line that point B is on, where am I going? Who can tell me? Where am I going? Alexis, what do you have for that one?
This one I did wrong.
Okay.
1 over 3.
So why did you say you did it wrong?
Because I did 5 up 3 over.
Okay, well, 1 over 3 is still the right slope. You still got it right. All right, so M equals 1 over 3. I went up 1, 1, 2, 3 to the right 3. Now, some other people do it this way. They do the run first. So I went over 1, 2, 3, up 1. I know some people do it that way. As long as you know, where does the run have to go? On the top or on the bottom? Bottom, right? Ryan, question?
If you go like up 5 and over 3, would it still be the correct answer?
If I go up 5 over 3?
Yeah, like if you did it
I
differently.
just switched it by.
So you said you
Yeah, I did that.
oh, you graphed it wrong?
Yeah.
Okay. So you did, so let's see. So we did
I did over 3 up 5.
over 3, up 5, 1, 2, 3, 4, 5. And then we did, what'd you do here? 2, 2 still? Same thing?
Yeah.
Oh, all right. I'm just going to draw it on the line here.
Oh boy.
We got 2 lines. So let's see. All right. I'm going to go up, right? 1, 2, 3. So my rise would now be 3. My run would be 1. All right, so you're getting the opposite there. All right, so you got to make sure when we give you these points, you got to make sure you graph them correctly. All right. Good with this one. So your M, your slope should have been 1/3. You can do it either way. Do the run first, then the rise, or do the rise first, then the run. Got it? Good.
I did it.
Yeah, right.
Next. All right. So now we talked about there's going to be two ways that we were going to graph points. We were going to graph slope or figure out slope. We just did one way. How do we do it? What's one way? Huh? Graph it, right? Okay. Now,
Why is graphing kind of a pain? You gotta have graph
you
paper.
gotta graph those points every
You
time.
have patience.
Yeah, you gotta pay. It's time consuming. So we got a faster way.
All right. So now, faster way. So when we have our points, right, we're gonna have an X, because remember, it goes in alphabetical order. I have my X, I have my Y. So I have X1, I have Y1. I have X2, I have Y2. So we're gonna get two sets of points, and you have to label them first. And this is probably a formula you guys have seen before.
Does everyone understand those numbers are not exponents?
No, that's why they're written on the bottom.
They just stand for first X, first Y, second X, second Y. That's
So
it.
it doesn't mean like move over one by one.
No, it's just saying we have X1 is the first X, Y1 is the first Y. You're gonna have two X's and two Y's.
All right, so for any 2 points, we got to label them. You have X1, you have Y1, you have X2, you have Y2. All right? And then we can figure out by using this formula, which you have on your thing. All right? We want to do Y2 minus Y1 equal over X2 minus X1. When I plug my numbers into that will give me slope. So on your notes, make sure you're writing in Y2, Y1, X2, X1. Now, Mr. Hager, would you agree that if we wanted to put Y1 first and Y2 there, does that work?
As long as we do that with the X's.
Yeah. If it screws you guys up, flipping back and forth, putting the Y2 first, you can do Y1 minus Y2, long as you do X1 minus X2 on the bottom. Another big thing I see kids make mistakes with. Don't put your X's on top. It doesn't work that way. Y's need to be on the top, X's need to be on the bottom. Ryan, question?
I've seen these before.
Yes.
I've seen them
You
before.
guys, you've seen this formula before, right? People have seen this before? All right, so make sure you have this down, because, again, this is just doing it without having to graph it. It's going to save you some time. But you got to make sure you fill it in correctly. You have this written down?
I do.
Guys, when we did it before, what word was on the top? Rise or run? Rise. So one way, if it helps to remember it, it rhymes. Rise, wise. Rise are on top, rise is on top, wise are on top. Okay? Remember that.
Does everybody have this formula? Okay. So now, on your thing, let me, you have the steps to find slope. So first thing you want to do, you want to write on your sheet, is label your coordinates. So this would be x1, whatever the first coordinate is x1, whatever that second coordinate is y1. Then you have your second set. Then you have x2 there, y2 there. So make sure what I do, so I don't get confused and I plug them in correctly in the formula, I will label them so I know. So label your coordinates, x1, y1, x2, y2. And then once we go through an example, it'll make a little bit more sense. All right? Next, you want to plug into the slope formula that we just wrote that down. Make sure those negative or those minus signs, that's a part of the formula. So say if like your y1 was negative, then negative still needs to go there. So it'd be like two negative signs. You have the minus, that's part of the formula, and then the negative sign that was part of the number that you plug in there. So if you have a y1 that's negative, you've got to make sure that negative sign goes there too. This doesn't just take the place of it because that's part of the formula. It needs to be there, and you plug in the two numbers. what I'll do sometimes, and I'll show you guys when we do one, I write my fraction bar and put my 2 minus signs first, so I don't forget. All right, so you plug into the slope formula. We talked about that. We just wrote that down. Number 3, we're going to solve. Now, this line right here, not the minus signs, but the line. What math operation does that mean?
Division.
Want to divide, right? Okay. So we have 3. When you're doing these, 3 things you want to look for when you're solving. All right? First thing, if the number on the top is bigger than the number on the bottom, do they go in evenly? So say if I had 4 and 2. So like Mr. Hager said earlier, we always want to try to reduce these. So I have 4 over 2, right? What would that reduce to? Does the number on the bottom go into the top evenly? Yes or no? What would it be, Sabrina? 2, right? So I always look, that's one question I have to ask myself. So that slope would be 2, or 2 over. My slope would be 2 there. So if the number on the top is bigger than the number on the bottom, check to see if they go in evenly. If they do, reduce it, or simplify it. Next, if the numbers can be reduced, reduce them. So say if you had maybe you had a smaller number on the top. Say if we had 3 over 6. The number on the top isn't bigger than the number on the bottom, but I can still reduce that. I can reduce that using what number? What number would I divide by to reduce that? 3 over 6. What number would I divide both the top and the bottom by to reduce? 3. Top becomes 1, bottom becomes, oops, not 3, 2. Bottom becomes 2. So that's another situation. If I can reduce it, reduce it. Okay? Last. If numbers on the top and bottom are negative, they're both negative, the answer is positive. So say if I had a -1, when I did my subtraction, I had a -1 on top, and I had a -2 on the bottom. What's the line mean again?
Divide.
Divide, right? So I'm dividing what by what? What kind of a number by what kind of a number?
Negative.
Negative by a negative, right? And we know that it becomes a positive, right? So that's why I see a lot of people make that mistake. Negative on top, negative on bottom, make sure you reduce them. Make sure you make them positive. So there's 3 big things that happen sometimes with this. That's it. So that's how you would set up the solve for slope when you're not going to graph it. And you're actually going to plug it into the formula. All right, so let's look at that first example. Look at 2a. So, find the slope in terms, so it gives me the 2 points, right? What does it say the first thing to do in my steps we just wrote down? Brian? Huh? Okay, I can go back up after, okay? What's the first thing I have to do in the steps we wrote down?
Wait. The graphic.
No, we don't have to graph these. We're not graphing now. Label it. Good, Caitlin. All right, so what would I label this, Caitlin? The 0 and the 4. This is going to be what again? X1, and 4 is going to be Y1. Good. Gabe, this set of coordinates, what do I label it?
1 over 3.
No? If this is X1, Y1, what's this going to be? X2, Y2. Okay? Now, like I told you guys earlier, I'm going to draw my line. I'm going to put my minus signs so I don't forget. What's the formula again? Who can tell me? What's the formula to find slope? Sabrina? Okay, so Sabrina's saying she wants to do it as Y1 first, Y2 second, X1, X2. That's fine. She's consistent. She's got Y1 on the top. She's got X1 on the bottom. That's fine. That works. So we can do it this way. That's fine. What's going to go here, Sabrina? 4. Minus is part of the formula. And then?
1 minus 1.
Excellent. Bottom. Kevin, what would I put on the bottom?
Your x, y, z, x, 2.
Okay, which are?
0.
Yeah. Excellent. I'm just going to erase this so it's out of the way. Now I solve. I just do the subtraction that it tells me. On the top, what do I get? Logan, what do I get in the top?
Positive 3.
Positive 3.
And then on the bottom you get a negative 3.
On the bottom, I get a negative 3.
Does it matter if, it doesn't matter, right, if you put like 3 minus 0 or a minus 4, right?
Say that.
Like instead of putting y1 in the
No,
bottom,
so you did it the opposite way?
Yeah.
That's fine. Well, again, if you have the second coordinate, so say if you have y2 first on the top, then x2 better be first on the bottom. Don't do y2 then x1 on the bottom. It doesn't work that way. You got to be consistent. What happens with this?
You had to reduce it.
To what?
I don't know. 1.
1, right? It would become, and make sure that it's negative. So it would be negative 1 over 1 or a slope of negative 1. Right, so m equals negative 1. I had a situation there where I could reduce it. If it comes out as like 2 over 5, leave it as 2 over 5. You don't want to make it a decimal. You don't need to do that. All right? Now, the next one, Mr. Hager had we changed this one a little bit. So make sure, double check, make sure you changed it. All right, your A should be 2, 5, and your B should be 2, 8. If you guys didn't change it. All right? I'm going to draw my line, put my minus signs. Davin, what would I label these?
X1 and Y1.
X1 and Y1, good. Samantha, what would I label these? X2 and Y2. Let's do it the opposite way this time. Let's do it with Y2 first. So if I'm going to do Y2 first, what's going to go here? Ryan, if I'm doing Y2 first. 8, good. Then what goes here, Ryan?
5.
Good. Excellent. Use those. How about on the bottom? Kevin, I already called him. Victor, can you figure out the bottom? Remember, I did Y2 on the top here, right? So how about the bottom? So I used Y2. I used Y2 minus Y1 on the top. What do you think I'm doing on the bottom?
Would it be 2 minus?
So you're going to say X2, which is 2, minus X1, which is 2. Excellent. What do I get in the top? Huh? 3, yeah, you know. 3 on the top. What about the bottom? 0. Now here's the problem. We talked about this at the beginning of the year. If I have a number on top, so I have an n on top, and I have a 0 on the bottom. What's that mean? What do we call that? What kind of a slope?
Undefined.
Undefined. Right? Remember, like Mr. Hager showed you guys at the beginning of the year. Number on top, 0 on the bottom. No, it doesn't work. It's undefined. Undefined for that one. All right? So undefined. Remember, number on top, n, 0 on the bottom, no. Last one. Guys, take a second, take like 30 seconds, and just set it up. Just like we've been doing, label it first, then plug it into your formula. Guys, I'm not going to go crazy and label this one, all right? On the top, somebody tell me what they got on the top. Kevin? 5 minus 5, good, I agree with that. How about on the bottom, Brian? All right, so we did what? So you had 4 minus 4. So we want to do this. This 4 is going to be x1, right? That makes this negative 4 what? No. If I'm labeling this x1, what am I labeling that? x2. Remember, we want to start with x2 first on the bottom, right? So I want negative 4 minus 4. All right? On the top, Kevin, what do I get? On the top, what do I get? 0. On the bottom, this is a little bit trickier. What do I get on the bottom? Who can tell me? No?
Negative 8.
Good. Remember, I'm combining now. I'm combining. I get 2 negatives, keep the sign, add the numbers together. So I get negative 8. What's my slope? What's my slope? M equals what? 0. If I have a 0 on top, number on the bottom, if I divide that, I'm going to get 0. So my slope is 0. All right, so we gave you an example of an undefined and also an example of a slope of 0. Homework, 11.1. All right, there's some stuff on there. I think there's 4 on there where you're given the graph. You have to figure out the slope. There's 4 on there where you get 2 points and you have to use the slope formula. And then there's 1 where it's a constant of variation, and there's 1 where a word problem that's constant of variation. So a little review stuff. Remember, guys, no class tomorrow, so that's due on Thursday.